You know, the thing about Ethereum is it's never really done. It isn't some static piece of technology. Nope. It's more like a living, breathing ecosystem that's always, and I mean always, changing to solve the new problems that pop up. So today, let's trace that evolution, right? We're going to go from its origins as a simple machine for trust all the way to the complex, high-stakes economic game it has become today.
And really, it all goes back to this core mission from the original Ethereum yellow paper. It was about facilitating transactions between people who just couldn't trust each other. So for a second, just forget about the money part, okay? The real problem, the big one, was trust. I mean, think about it. How do you get two total strangers who could be on opposite sides of the planet to make a deal and know with total certainty that nobody's going to get screwed over?
Well, before Ethereum, the only way to get that kind of trust was through a middleman. A bank, a credit card company, the legal system, these big institutions. And let's be real, those intermediaries are often slow, they're expensive, and frankly, they're not even an option for a lot of people around the world. So Ethereum's big idea, it was pretty radical. It was like, what if we could just get rid of them? What if we could build the trust right into the code?
So to pull this off, Ethereum was built as this whole new kind of global computer. I want you to picture a giant universal ledger book. It starts on page 1, what we call the Genesis state. Now, the only way to write something on the next page is if the entire network agrees that what you're writing is valid. That's really it. The nerdy term for this is a transaction-based state machine, and honestly, it's just a super elegant way to create one single shared history that everyone can believe.
Okay, so how does this global computer actually work? I mean, how does it process all these transactions and get everyone to agree on a new version of reality, like every few seconds? Let's pop the hood and break down the core logic.
All right, deep breath. At the absolute heart of everything is this little formula from the white paper. And yeah, I know it looks super intimidating, but I promise it's just a really fancy way of saying something simple. It's basically the new state of the network is just the current state plus a new transaction. That's it. That one line is the whole idea.
In the real world, it plays out like a simple 4-step dance. Step 1, the whole network starts from the same agreed-upon beginning. Step 2, a user sends out a transaction. Step 3, every single computer on the network checks it out and runs the instruction. And then, step 4, boom, they all land on a brand new identical state. And this little dance just repeats over and over and over, building up that secure, shared history, one block at a time. But look, this global computer isn't just some abstract concept floating around in the cloud, right? It's powered by a network of actual people running actual computers all over the world. We call them validators. And these folks have real skin in the game. They put their own money on the line. They stake it to help secure the network and, keep everybody honest.
And yeah, the idea of becoming a validator, it can be pretty intimidating. This quote from a Redditor, Meshly, just captures that feeling perfectly. You can feel the mix of excitement and, honestly, a little bit of fear. They're saying, hey, this is my life savings. I needed to start earning something. They want to put their assets to work, but it's everything they have. And you can hear the questions in their mind. Is this going to be too complicated? Am I going to mess it up? Is it too risky?
But here's the cool part. The community has really stepped up to build tools that make it way, way easier. Check out this comment from another user, Yogafubi. They say they have basically no programming experience, but using something like Rocket Pool was pretty easy to set up. And the best part? Ongoing maintenance takes them about 5 minutes a month. That's huge. Making it this accessible is absolutely crucial for keeping the whole network decentralized.
Okay, now here's one of the most backwards-sounding parts about being a validator. It's about choosing your software. Common sense tells you to go with the most popular option, right? The one everyone else is using. Safest bet. Well, nope, it's actually the opposite. See, if a bug hits that majority client, a massive chunk of the network can go offline all at once, and the penalties for that are severe. But if you choose a less popular, minority client, you're not only protecting yourself from that, you're actually making the entire network more resilient. It's a win-win.
So, mission accomplished, right? Ethereum solved the trust problem. It built this secure, decentralized network. But it kind of became a victim of its own success. Its popularity created a whole new problem. As more and more people piled on, the network just got clogged up. It got super congested. And that meant long waits and, you guessed it, ridiculously high transaction fees.
The big solution that emerged was something called Layer 2 rollups. You can think of them like express lanes on a highway. They take hundreds of transactions,
bundle them all up off the main chain, and then just post a tiny little summary back to Ethereum. And this helped a ton. But there was a catch. They still had to pay this kind of data tax. They had to use an expensive part of the transaction called Calldata, because that data had to be stored on the main Ethereum chain forever, and that was costing them a fortune.
And then everything changed. A massive upgrade called Dencun came along, and it introduced a total game changer for Rollups to post their data, something called Blobs. Now, the key insight here was a total aha moment. Someone realized, hey, this data, it doesn't need to live on the main chain forever. And by making it temporary, these new blobs became drastically cheaper.
So you see, introducing blobs wasn't just some minor technical fix. Oh no, it fundamentally rewrote the economic rules of the network. It created a brand new marketplace with its own supply and demand, a whole new game that block builders and rollups suddenly had to learn how to play.
And the impact? It was immediate. It was dramatic. I mean, almost overnight, the average size of an Ethereum block more than doubled, jumping from about 150 kilobytes to nearly 400. And all this new space wasn't for your everyday transactions. It was almost entirely being filled up by these new, massive blobs.
The migration was just swift and absolute. It's like all the rollups flipped a switch. The old, expensive Calldata, it went from over 7,500 daily uses down to basically zero. It became a ghost town. And at the exact same time, Blob usage just exploded, from nothing to around 10,000 transactions a day. The game had well and truly changed.
But here's the twist. Here's where it gets really interesting. Even though blobs have been this massive success, the new market for them is, well, it's surprisingly inefficient. In fact, research shows that almost a third of all blocks that have blobs in them are built suboptimally. What does that mean? It means block builders are literally leaving money on the table. They're not making as much as they could be.
So that leads to the big question, right? Why? Why is this brand new marketplace, this new economic game, being played so badly by so many of the players?
Well, a huge piece of the puzzle is in the strategies the rollups themselves are using. See, the smartest, most efficient thing to do is to bundle a bunch of blobs into one single transaction. That saves a ton on fees. But what we're seeing most of the time is the exact opposite. Rollups are splitting their data up into a whole bunch of separate transactions, which is just way more expensive and inefficient.
And when you look at the numbers, it's pretty staggering. Almost 70% of rollup transactions are just carrying a single blob, even when bundling is the cheaper option. And we're seeing some really weird strategies, like some projects sending the exact same blob multiple times, or just a constant stream of single blob transactions into the same block. And look, these aren't small mistakes. This has already cost these rollups over 186 ETH in just completely wasted fees. That's a lot of money down the drain.
And this really brings us full circle, back to where we began. Ethereum is always evolving. It started as a trust machine, then it became a global computer, and now it's a complex economic arena. The blob market solved the massive fee problem, but in its place, it created this fascinating new strategic game. And so the big question for the future is, who's going to adapt the fastest? Who is going to be the one to master the rules of this brand new game?
Stay ahead in the crypto market. Subscribe now for the latest global news and updates.